All right, happy Thursday. In class, we talked about the 210 ready and go. You should have those papers in front of you, and I'm just going to get right to it. In the ready, if you read the bold sentences at the top, it talks about a guy hitting golf balls off a cliff, so into a lake. So here we go. Here's the lake. Here's the cliff. And yep, go ahead and laugh. But here is the guy hitting the golf balls off the cliff and into the water, and here we see it splash. All right, splash down. Well, that's the scenario that we see. If we go below that, it gives us these three forms of an equation. It tells us they're all the same. They're all the same, they're just in different forms. Question number one that it asks us is, which expression is best useful for finding how many seconds the ball will hit the water? Well, and in most classes I got silence. I'm like, wait a second, time out. Let's go back and revisit this diagram. Don't look at it as a guy hitting golf balls into a water. Look at it as you see an x-axis, you see a y-axis, which would be here. This is going to continue down. The x-axis is going to continue over, and the y-axis continues up there. Can we identify key features of, gee, this looks like a parabola? Yes, we can. And let's just start from the top down. I can identify a vertex. I can identify this point here, which would be a y-intercept. I can also identify my axis of symmetry. And if I can continue down further, this point here would be a an x-intercept. And since it's a parabola, we have two x-intercepts. Well, I don't see the other one. Yeah, we don't see the other one. Whoa, we don't see the other one, but it exists, and it exists over here. It's just hidden. Okay? So we'll call that the other x-intercept. So there's my key features. Which of these equations tell me the key features? That's what we've been building up to. Which one tells me at what time it's going to hit the ground? Well, remember what your factors do. My x-intercepts are actually the opposite of my factors. So in this particular problem, positive 6, negative 2. Negative 2, positive 6. Question number one, we pulled that out of factored form. And the reason why is because the factors, and you can copy this down, the factors tell us the x-intercepts. Make sure you include y. I'm not going to write it down for you. Rewind if you need to. The factors tell me what the x-intercepts are. Question number two, which form is best for determining the height of the ball? Well, the maximum height of the ball, I should say. It says maximum height. Well, where's the highest point of where the ball is? It should be right up here. That would be the vertex. The vertex is also known as h and k. The h value tells me right or left. The k value tells me up or down. So look at vertex form, and it tells you 78.4. Why? Why? Answer the question, why? Because the k value tells me the maximum height. Write it down. Rewind if you need to. K tells me maximum height. Question number three. Which equation is best to tell me what the height of the ball is after 3.5 seconds? Well, let's go through and do a little bit more background here. Let's label the x-axis, not number it, because by now we should know that this would be negative 1, 1, 2, 3, 4, 5, and then we get over here to 6, right? Not number it, but label it. What is 6? Well, if he hits the ball, 1, 2, 3, 4, 5, 6. 6 is a function of time. He hits the ball and it goes up and has a height. That is a function of height. So now when I look at it, time and height would be my table of values. T in this equation would be my input. H would be my output. So if my input is 3.5, well again, which form best helps me determine the height of 3.5? The question here, and I hope you can see this, is any of them. Why? They're all the same equation. They're all the same equation. So if they're all the same equation, no matter what my input value should be, 3.5, 3.5, I should get the same output. Here, same output. Here, same output. I might choose vertex form because I only got to input 3.5 one time versus the other two I got to input at 2. But it doesn't really matter. All right? And then finally, question 4. Which one helps me determine what the y-intercept is? Okay? Well, how far above the cliff, how far above the lake is the cliff? Or what does this represent? It represents the y-intercept. Well, hopefully you're saying standard. And some of my students say, well, gee, it's the only form we haven't chosen. Well, that's true. It is. It's the only one we haven't chosen. But why is standard form the best for determining the y-intercept? What does ax squared plus bx plus c, what do these numbers represent? A, I've been telling you, represents up or down, stretch or shrink. B, nothing. C, y-intercept. Okay? The c value tells me the y-intercept. All right? So again, look at this. Don't look at this as a picture of a guy hitting golf balls. Look at it kind of mathematically and look at all the things we identified and we're able to find with our equation. Knowing we have our equations. All right? I'm going to test you on something like that. I'm going to give you all three and tell you, find this information. It should be easy. All right, the next thing you have to do, the go. In the go section, you need to pick 2 of the 4 from 10 through 12. You need to pick 2 of the 4. And it's asking you, do the factors match the equation? So multiply. That's all it's asking you to do. All right? I don't really feel at this point I should have to explain that to you, but do these given factors, when you multiply them, first 2, outer 2, inner 2, last 2, are they equivalent to x squared plus 5x plus 6? Are these equivalent? That's all they're asking. Multiply this way or multiply using the box method. Doesn't matter. Right? So you got to pick any 2 of those. Now the last section, you got to pick 5. Right? Any 5 you want to do. We're going to do the first one. X squared minus 5x plus 6. How do we factor? How do we factor? I'll use this in a second. We factor by multiplying a times c. 1 times 6 is 6. List my factors of 6. It's been a while since we've done this, so this is why we're reviewing. 1 times 6, 2 and 3. Which factors of 6 will give me a negative 5? Well, this is where the thought comes in. Minus 6 plus 1 is negative 5. Yes, that's true. But I want to find factors that add to equal b, but multiply to equal c. 6 times 1 is 6, but negative times a positive is negative. The problem they give me is a positive 6, not a negative 6. So minus 6 and positive 1 don't work. The only other factors I get to choose from are 2 and 3. Well, in order to get a negative 5, I get a minus 2 and a minus 3. If I add those together, I get negative 5. If I multiply them, I get positive 6. So right here, and here's my factors. X minus 2, x minus 3. Done. That's it. The other part of this is the directions say some are not factorable. Okay, so this is the example I chose to show you something that's not factorable. List my factors of 6, so 1 and 6, 2 and 3. So you've done that. You've listed your factors. Which factors of 6 will add to give me negative 8? I hope you said none, because that just means this is not factorable. If there are no factors that give you b, it's not factorable. Again, there's that one, and pick 4 others in that section. Make sure you turn it in by the due date. Ask questions if you need to.